All right, so we'll start from the beginning a little bit just to make sure that we have covered some part in the recording. So I was talking about what are the goals. Today we will learn about understanding the core ideas of generative AI, differentiate generative AI from classical machine learning, and also learn basics of prompt engineering, RAG, and agents. So as the name says, generative AI means the AI that generates new content. The content can be in the form of text, code, images, audio, or video, and all of it, right? The core component which does this is some kind of a large language model or foundational model. So generative AI is not a buzzword. It creates things, and we have already seen using ChatGPT. It creates text, music, designs based on patterns in the data. The LLM is trained on. All this content generation is happening using large language models or foundational models. Before I jump on to the next slide, I want to give a brief difference between large language model and a foundational model. There is a subtle difference, but people use one or the other. It doesn't make much difference. A large language model is a model which is trained on language data. For example, like it understands the English language, any language which the model is trained on, right? Some models have been trained on multiple languages. Yeah. So any model which is trained on natural language is called large language model. But foundational model is a broader concept. It actually means the model is trained not only on text and language, but also on images and charts and etc. Right? So that means it can understand more than text. So if you give an image and try to ask ChatGPT what this image is all about, or caption the image, it will give you that caption. It will understand. It will try to understand the image, and it will give the caption related to that image. So that's the difference between foundational model and large language model. Large language model is also a foundational model, and you can use synonymously, but there is a slight difference between these two. All right, so we have already seen the examples of generative AI. We have already been using ChatGPT for our text generation. There are other applications like Midjourney uses Midjourney application. You can use to generate images. You can use GitHub Copilot for generating code. Sora is another application which is from OpenAI for generating videos. So why generative? For learning anything, before I jump onto the why, right? For learning anything, human. I think someone can go on mute, please. So I'm hearing echo. So for any learning, right? The first thing we need to do is generate why, how, and what, right? So that's why my presentation is more focused towards this why, how, and what, so that we can not only understand but also remember those things, right? So that's why generative AI is important. It is important because generative AI has revolutionized automation of creative and cognitive tasks. It has enhanced the productivity for anybody, and it has disrupted almost every industry. Think about any industry like healthcare, travel, finance, and education, right? Almost everywhere AI is being used currently. And the best advantage of AI is it empowers even the non-experts to build something. As long as you know language, natural language, like as humans, we know how to write at least, right? and we can give a prompt to a LLM and it responds. So as long as we know what we want to do, we can just give an input to the LLM and it responds. So that means I need not be an expert in that field to build something. So that is the best use of AI. Okay, so now since we understood why generative AI, let us understand the basic of what is this, what is artificial intelligence, what is machine learning, and what is deep learning, and how it is related to data science. So data science is a very bigger concept. So data science is all about extracting knowledge and insights from data using statistics, machine learning, and domain expertise. So this is not new. Data science was always there since very long time. And the goal was to understand and solve business problems using data. It involved data collection and cleaning, analysis and visualization, model building and storytelling. So examples like analyzing customer churns, A/B testing, if you are aware of A/B testing for website changes, and predicting sales trends, right? All of this was there even before. So I was working for one of the project, and we had a very big application, and we were capturing how the users were purchasing the products, how before purchasing the products, what all pages they visited, and every page they were visiting, we were capturing the trace behind the scene, in the form of logs and traces, and we were then using data science algorithms to generate, analyze the pattern and come up with a trend of how users behavior is before they actually purchase an item. So that was machine learning. So machine learning was always part of the data science, and data science was always there even before these large language models became famous. Okay, so what is artificial intelligence? So artificial intelligence, so you can see this big gray circle is encompassing all of this. So it is intersecting with all these different fields like artificial intelligence, machine learning, and deep learning. So what is artificial intelligence? Artificial intelligence is the science of making machines think and act like humans. Okay, so the goal here is to mimic human intelligence, which includes reasoning, learning, planning, and language and vision. When I say vision, it means when I give an image to ChatGPT, it can visualize that image. It can see the image, even though it's a computer. I mean, behind the scene, it is operating in bits and pixels, right? It takes the image, breaks it down into pixels, try to see, analyze how one pixel is related to another pixel, and then visualize that image. We as humans, we see the image, we can identify using our own intelligence, right? The light from the image goes into our conscious brain, and then we can make out of it. But computers don't have any brain. They have to actually visualize the image using pixels, and they establish the relationship between one pixel to another behind the scene, and it's a very complex process. Think about it, how humans might have thought computers can visualize one day images as well, right? So examples, you already know ChatGPT can identify images, and self-driving cars, face recognition, all this is AI, right? And machine learning is a subset of AI, where machines learn from data instead of being explicitly programmed. So goal is to make predictions or decisions based on the data. So there are different types of machine learning. Where one is the supervised, wherein you feed the uh, the the algorithm, you feed the data into the algorithm, and you make tell the data that okay, this is um, you label the data basically, and you tell okay, I have 10 images of rabbits, each having different orientation in which the rabbit is actually walking or running or whatever, right? And then you give it to the computer, and then you tell in the that this is a rabbit. You tell the algorithm that okay, this is the rabbit, and later on it as and when you keep feeding the data, it tries to improve the understanding of okay, this is the image for a rabbit, and then it uh, understands that okay, if I get a new image, similar image, I know how to identify, right? So that is supervised learning, where you feed input data, you feed the output. Output is the image of rabbit, input is different images of rabbit. You tell, and you'll have labeled it as rabbit, and that's how it understands okay, this is a rabbit image. And next time when you give a different image which it has not seen before, then it can identify it as a rabbit. So that is supervised learning. So in unsupervised learning, so usually most of the machine learning algorithms are supervised in nature. For example, you might have seen Gmail sometimes identify some of the emails which it has not seen before as spam, right? How it is identifying? Because behind the scene, all the emails from relevant people or relevant contacts you might have already opened those emails, you have already seen those emails, and that is why the machine learning algorithm behind the scene knows okay, these emails are relevant and they are important for you, or they are coming from your contacts, and that is why it is keeping them in your inbox. But if it sees an email from a completely different contact from an unknown source, it might put it into a spam folder, because the machine learning algorithm might see that okay, it is an unknown source. Some people might have already tagged it as spam. Let me put it in a spam folder. It will still be in your mail server, but it will be in a spam folder, and then you have an option to go and make it non-spam or something, right? That's how machine learning is operating. So we are seeing the usage of machine learning, but we don't know what is happening behind the scene. Okay, so that is supervised learning, wherein it identifies some certain patterns based on the behavior of the user, and then it is labeling them as spam or not spam, image of rabbit or not an image of rabbit, something like that. So it is very deterministic in nature. Unsupervised, there is unsupervised learning also, wherein the machine learning algorithms will be fed with lot of unstructured data. For example, log data, or data which is not labeled. So most of the data today in the real time real world applications is unstructured data, right? The data which is coming from clicks, user clicks, clicking applications, pages, whatever. The data coming from logs, the data coming from traces, right? All this data is unstructured data, and it is humongous amount of data. And that data, we cannot label it, right? Because no human can sit on a computer on billions of megabytes of data or gigabits of data, and then label it. Okay, this represent this represent that, something like that. So they have to actually let the machine learning identify the patterns on the data, that unstructured data, by seeing the same data again and again. And that is how the unsupervised learning is all about feeding the data, the unstructured data into the machine learning algorithm, and then the machine learning algorithm then identifies that data somehow, and it classifies that data, right? So maybe say you want to you are there is a cricket match going on, and you want to you have fed the different scores and the way the players are playing and all that, and then it classifies who is the top player, who have played not played well or something like that, right? It creates a board. So and that data, that classification happens through a machine learning algorithm, but it is completely unstructured. No one has labeled it. The computer itself is identifying the patterns with the data, and it is able to generate the output. So that's unsupervised learning. There is another form of learning called reinforcement learning, and this mostly it's also called reward-based learning, where the computers, the machine learning algorithm learns from the human feedback or the feedback from the user, right? Say for example, you're driving maybe a Tesla car, and you see a roadblock, and you have slightly you moved the car away from the roadblock. Then the machine learning algorithm knows, okay, when it sees that block of something on the road, it needs to turn the steering little bit away from it, right? And that's how it knows that, okay, the behavior should be it should go away from that particular object on the road. Otherwise there can be a crash, right? So that is how the who has given that feedback, the user has given the feedback, and that's how machine learning now identified, okay, so when I see that small object or whatever, and even if the machine learning algorithm didn't have the feedback, it would have directly went through that. But since the user has moved away the car from that, so let me from now onwards move away the car from that particular smaller object which is on the road. So that's how it learned that behavior, and it is now able to reinforce that behavior in going forward. So that's called reinforcement learning. And spam email, so examples, I already gave you some of the examples for machine learning is spam email detection. Okay, Netflix recommendations is another, where you go and or YouTube recommendations, right? When you see similar videos, when you see one or two videos, it will keep recommending similar videos in your dashboard. How it is doing that? Because the machine learning algorithm identified the behavior behind the scene, and what you like and what you dislike. And fraud detection is another example. In banking applications, if all of a sudden we Muslims don't drink, right? And all of a sudden there is a purchase for alcohol on our credit card, then immediately the bank knows, okay, this user never purchased alcohol before, so why there is a charge for alcohol, and it immediately flags that transaction, and it intimates saying that, okay, you might have not authorized this transaction, and then you go and, okay, you cancel the transaction, or you let the machine algorithm know automatically that, okay, I didn't do this transaction. That's how it is able to prevent the fraud. So machine learning, these are the examples: machine learning versus generative AI, right? This is the main difference. So the core idea is the machine learning algorithm learns patterns to predict outcomes, and generative AI learns patterns to create new content. So the input for machine learning algorithms is structured data, numbers, labels, etc. And for generative AI, it's mostly unstructured text, images, audio, etc. And the output is usually deterministic in case of machine learning, where it predicts something, it makes a decision, or it classifies, right? But here, generative AI output is non-deterministic in nature. So I want to put little stress on these two terms, deterministic and non-deterministic. When I say deterministic, I expect the same output always when I give same input, right? That is called deterministic output. When I give same input, the output should be the same. When I give same input, if the output changes, then it is non-deterministic, right? So for example, if I give 1 plus 2, yeah, the answer should be 3, right? When I give 1 plus 2, if the answer is 4, it is non-deterministic. Even though that it might be an error, but it's still, when I give 1 plus 2, it should always be 3. That is deterministic in output. When I give 1 plus 2, and if answer is anything other than 3, then it is non-deterministic. So machine learning algorithms are mostly deterministic. That means they know if you give the same input, it will always produce the same output. But generative AI is not non-deterministic. That is the biggest issue we have in automating some of the workflows in generative AI. That's why in mission critical applications, right, they don't go with generative AI because it's very innovative in nature. So for the same input, it might produce different output in different times, right? And that becomes a bigger challenge when we actually go and automate some of the workflows based on Gen AI, right? The large language models. So this is the biggest difference. Examples for machine learning: fraud detection, product recommendations, and for generative AI, we already know we are using ChatGPT, GitHub Copilot, and DAL is another model which we can use. Model types, we have decision trees, SVM regression, and these are the models we have available for machine learning. For large language models, we know generative AI, we have transformer-based models like ChatGPT, GPT-3, GPT-4, Llama, LLMs, right, diffusion models, etc. So learning style is supervised, unsupervised. It is self-supervised. You see, pre-trained on large data sets. Data scale, usually it is internet scale, massive data sets in generative AI. It's very specific data set. That's why it is very deterministic in nature. Control over output, you can see it is deterministic. Creative and prompt driven. Use cases: risk scoring, churn prediction, anomaly detection. And it is mostly in innovative tasks like content creation, conversation design assistance. Relationship is broader field. This is subset of ML focused on generation, right? So this is the main difference between machine learning and generative AI. So the best analogy for machine learning versus generative AI is a calculator. I was giving the example 1 plus 2 equals 3. That means behind the scene, it is very rule based. Behind the scene, it is very rule based. You know what output can come when you give certain input, because it's statically coded within the calculator that, okay, if I input 1 plus 2, you need to give 3, right? You can never expect it to go wrong because it is rule based. It is coded that way, and it will always predict the same output. But generative AI, it is creative in nature. If you give same input, as I said, it might give different output. So it is innovative, creative in nature, and that's why it can be used in chatbots. It can be used in various other applications like content creations. That is that is the best analogy: calculator and the bot, right? And since humans also non-deterministic in nature, it suits well for us to go with generative AI, because most of the tasks we do actually in the real world are non-deterministic in nature, and it keeps changing, right? All right, so that finishes our Gen AI concepts topic. Now we can move to prompt engineering. Before I jump on, do you have any questions? I want to take a pause here. All right, no questions? All right, let's move to prompt engineering. So what is prompt engineering? Why we need it? Prompt engineering is how you talk to Gen AI models. It's like learning a new programming language. Of course, it's natural language. Prompt engineering is a process of designing and refining input instructions to guide AI models, particularly the large language models, towards generating desired outputs. It's like providing the AI with a roadmap, helping it understand your intent and respond in a meaningful way. For example, how ChatGPT knows when you say what is Apple. So unless and until you tell Apple fruit as a fruit or Apple as a company, ChatGPT will not be able to respond, right? So your prompt should be very specific. Your prompt should have little bit of context. Then only the ChatGPT or any other large language models can respond properly. And that is the art of prompting. So you have to give proper context before you ask a question. You cannot just say what is Apple. You have to see what is Apple as a company, what is Apple as a fruit, right? Then it might understand the difference between, okay, you're talking about Apple as a company or Apple as a fruit, right? Then it can give you relevant answers based on that. And so that is why your instructions to the AI should be clear and should be structured, and you can iterate and refine them once you actually um, learn from the output, right? Based on what output you get, you can just keep refining that. So that is the art of prompt engineering. So there are different types of prompts, okay? And in the prompt engineering, one is called zero shot. Another is few shot, and the third one is called chain of thought. Okay, the good prompts will give you better outputs. So I'll give a difference between zero shot, few shot, and chain of thought. Okay, so let me go to my browser. Okay, and this is my zero shot prompt. Okay, give me a tweet on Apple as a fruit. See, it knows clearly what I'm asking, and it was able to respond properly, right? That's zero shot. So next, if I have to give one second, if I have to give the few shots, the few shots prompts are actually prompts with an example. See, here I have not given any example on how I'm expecting the response, right? So let me give this prompt now. Okay. So the odd numbers in this group add up to even numbers. The answer is false. Okay, and see, I'm giving examples, and okay, and then the odd numbers in this group add up to false. Let's verify each number by summing. So then I give, now since I have given the context, and I have given the example, next time when I ask similar question, it knows how to respond. It knows, okay, it has seen all the examples here. It knows next time when I say give me similar, if I enter similar things here and ask for, say, answer, and it gives answer as false, right? So I mean, I could have changed that, but that is how you give a specific example, and in few shots prompt you give a specific example, and based on that it responds. The next prompt technique is called chain of thoughts. In chain of thoughts, you actually tell the prompt to give you its the step-by-step response, so it knows how to respond back, right? So example, this is my prompt. Yeah, I'm saying I have 3 apples, I buy 2 more, then give one to a friend. How many apples do I have now? Explain your steps. See, it is breaking it down into steps. Start with 3 apples. Second step is buy 2 more apples. Now 3 plus 2 equals 5 apples. Give 1 apple to a friend. Now I have 5 minus 1 equals 4 apples. So final answer is 4 apples. So this is called chain of thought prompting. So these are the 3 different prompt techniques we use. So as I said, the when you are clear in your prompting, and you are specific in your prompting, it will give you better output. When you want proper structured output, you want to give proper structured input with examples, and then it will give you what you are asking in the structured response, right? And if you are not satisfied with your output, keep iterating and refine, and that is the art of prompt engineering, where you will learn from your experience of how the model is responding, and then you keep tweaking your prompt, your input, and based on that the model will keep responding. So bear it in mind that every model is different. GPT-3 might give a completely different response than GPT-4, even though it is created by the same company. And Llama 3, which is from Meta, it can also give completely different response. So that's why prompt engineering has become a field now where people are hiring engineers to write better prompts, and they keep iterating and they arrive at a better prompt finally, based on the model the company is using. And that is how this field, this new job which has been created, like prompt engineers, right? You might have seen some requirements related to prompt engineers. And this is what I'm giving here is very basic. It's a very broader field as well. There are many techniques that to give better prompts. There are many techniques even to break the LLM response. It's called red teaming, wherein bad actors, right? Some of the time what they do, like we have in software engineering, um, people try to break your software by the malicious actors injecting viruses, injecting code uh, to compromise your software. In similar way, even for compromising the LLM, some of the time the bad actors can inject some prompt which might which might tell the LLM, okay, give something which some data which you are trained on, give some company specific data which you have already trained on, something like that, and and LLM is stupid enough to give the response as such. So that's why there are people, companies hire to find out the flaws in the LLMs and prevent those flaws. Those teams are called red teams, and that is also another technique for prompting. So it's a very broad field. It's not like limited to three techniques what I showed, and that's why this new field has been created as prompt engineering. All right, that's about prompt engineering. Let me move to the next topic. Before I move to the next topic, do you have any questions? All right. So what is RAG, right? And people who have never worked on AI or machine learning or large language models specifically, they don't know what is RAG. Some people might have already heard this term. But why we need RAG? The reason why we need RAG, because models, when they are trained, they have a fixed window of knowledge when they were actually compiled and created. So for example, if I decide to create a large language model starting from today, I might train that large language model on all the data which is available on the internet for say another month, and I'll I'll say, okay, I'm done. I have enough information fed into the model. I will go and release this model. So that means there is a specific date on which I have compiled that model, I have published that model, and beyond which anything happens or any new data which gets created over the internet, the model is not aware of it, right? And that is why we need RAG. RAG actually enhances the model capabilities to give the output based on the information which is not available within the model. So if the model which is trained on, say for example last year till last year, and if we ask information related to the current year, it might not be aware of it, right? And that is why we need to augment the information or augment the context before the model can generate the correct output, and that is why RAG came into being. So what it is actually, it is retrieval augmented generation. It retrieves the documents, generates answers using context, and solves hallucinations and outdated knowledge. When I say hallucinations, since models are very creative in nature, which I already talked about, what it does is, if it doesn't know something, it tries to hallucinate. It tries to give you an answer with clear confidence that this is the answer, but it will be 100% wrong, right? That is hallucination. And that's what we want to prevent. We don't want models to hallucinate and give with clear confidence an answer which is completely wrong. We want to augment the model information if it is outdated, and if you want it to be if you want it to give the correct output. So that is why we need RAG. So this is the basic architecture of RAG. You give the input, you will look up, you will create a database. Okay, in this case I'm showing a database, but it can go to the internet, it can browse information from the internet based on your query, and it can give that information to the large language model as context, and then the large language model knows, okay, this is the context, and based on that context it will give correct output, right? So this database scenario comes in when you want to feed something which is not available on the internet, right? For example, if you want to give some information related to your company, which is very much proprietary data, which you don't want to expose on the internet, and you have built a application like a chatbot, and you want your customers to only know the information based on the query they are giving, relevant to your own company data, then you actually create that database through and this retrieval mechanism actually retrieves that data and gives that information to the large language model. Okay, so in this scenario, so it happens in every company. Not all companies expose their proprietary data. They will have their own internal databases, language knowledge bases, and through which the data can be retrieved and can be fed to the large language models, and then the output can be generated. Now you might ask, will ChatGPT will be able to give data from Google internal documents, or based on this diagram, right? Or any other company, say Visa or anything. So it will not. ChatGPT will never be able to see the data. This whole setup will be built by the company in their own environment, and they will actually use one of the foundational models, large language model, to only serve their own customers, right? So ChatGPT will never be able to give information from any, say, company X and company Y, because they can never see that data. Only if company wants to make that data available, then they will have to build this setup internally within the company. Then they will be able to serve the customers with their proprietary information what they have in the company. The information can be, okay, my product X costs this much, my product X has these many features, right? This is the security built into that product and all that, and that might not be public information. It might be very much within the company. So that's what the company will be exposing through this setup. So, and there are many different RAG architectures. What I'm showing here is a simple RAG application, but there are other RAGs wherein you will built in memory within the RAG setup, where the LLM knows what it answered previously, and based on that relevant context, it will give the next output. There are other, and this database which I'm showing, it is currently one database, but it can retrieve from multiple databases. That's called branched RAG. There is also another RAG called hypothetical document embedding. There is another RAG system called adaptive RAG. It adapts based on your query. If the query is simple enough, it will just pull the information from one database. But if it is complex, it will go to multiple sources to retrieve the context, and then it feeds to the LLM to get the output. There is also a corrective RAG wherein it self-reflects on the retrieved information, and it tries to see, okay, if this information is correct enough for me to feed into the model, and then based on that it will actually correct the information. It might go retrieve it again from same source or different source, and then it will feed it into the language model. So that is also, so the complexity increases as the use case demands, right? So if the use case is simple enough, you can build this. If the use case demands more complexity, then you go to different architectures. And there can be another RAG, and it is now famous. It's called agentic RAG. Agentic RAG actually calls not only the relevant information, it will call multiple sources within your company, but it might call the internet. It might call internet to browse through the internet to get the relevant information. It might feed it into the LLM. It might call other tools also. That's called agentic RAG. So there are different setups based on the use case you might want to build. That's about RAG. As I said, RAG use cases: chatbots for support for your company, knowledge assistants if you want to give some relevant information which is not publicly available. That's another use case, and something which is very proprietary, which you don't want to expose over to publicly to everyone. Then you might go with some kind of specific use case like legal or healthcare document search, right? So you have logged into your own healthcare portal. and you want to search your health related issues or whatever, right? In those cases, you can build your RAG application. All right, the next topic. So that's about RAG. The next topic is AI agents. So I talked about RAG, why it was needed. So the next extension to RAG, right? We talked a little bit briefly in the last topic. Agents, agentic RAG. I talked about agentic RAG. What are AI agents? AI agents are actually applications. And I have many DevOps people here. Abdul Wahab bhai is a DevOps person. So these guys, so what previously we used to do, what DevOps team used to do is we developers used to build the applications, and DevOps team was helping us deploy those applications, creating pipelines and all that, right? AI agents are kind of applications, but they are very much focused towards LLM, and they are actually deployed as applications. So pretty much for DevOps team, nothing much is changing. There is another DevOps called LLM Ops, which is completely based on machine learning, how to actually train the model and extract, first of all, extract the data, create relevant features out of it, and then feed the data into to create a machine learning algorithm, and finally publish that machine learning algorithm. That is LLM Ops, which is completely different field. But if you are only on the Gen AI side, then for DevOps team, nothing much will change, because all these AI agents are nothing but applications themselves. But instead of hard-coded logic within the application, now we are going and interacting with an LLM and then generating the output. And if the output demands, I need to call another application, I will go and call that application, and I might come back to the LLM again asking, hey, is this enough for me, or I need to go to another application for that. That means I'm building a complex set of applications, and each time the decision maker is LLM. So this is instead of previously what we used to have a program which used to decide, okay, I will call API A, and then I will call API B, and then I will call API C, right? Now, instead of that program, I have a LLM which is calling, say, API A, then I will come back to LLM. I will ask LLM, okay, API A gave me this output. What should I do with this? LLM then decides, okay, let's go to API B, and then we will go to API B, and then it will again the response will come back to LLM. LLM decides, okay, now instead of calling API, let me call the database, okay, and then I will go to the database. Then instead of calling then I will come back to LLM again, and again LLM decides, okay, instead of calling the database, let me go to a Word doc, maybe another tool, maybe Splunk or something, and retrieve the information from Splunk, right? So here, who is the program? The LLM is the program. It's acting like a program. Previously, we used to have a static set of program which actually was deciding how to orchestrate the flow. Here, LLM is orchestrating the flow and actually combining the results from all these different tools, APIs, etc., and finally, arriving at the goal. So basically, what is important here? The goal is important, right? So so agents are nothing but LLMs that plan and act. They can call tools, APIs, and take actions. They think, plan, act, and reflect. Okay, when they think, that means LLM is thinking. Then it plans, okay, what I need to call, API or a tool. Then they act. They actually call that particular API or tool, and then they reflect. Again, it will come, and when the output comes from that particular API and tool, it will reflect on that, and it might repeat the process again. That is agent. So this is AI agent. See, it is calling database, it's calling local file system, it's calling APIs, it's calling sensors. I mean, you can think about anything you can call, as long as LLM can understand the output and LLM knows how to call that particular tool or particular uh, component, it will invoke it and it will get the response back, and then it decides what to do, and then it will keep doing that until it arrives at your output. So AI agents can understand tasks, okay, plan steps to solve them, use tools or APIs like calculators, search the web or databases. Then they take actions and adjust based on results. Okay, the main components of AI agents are goal. What you are trying to achieve? That's your goal, right? Then the second component is environment, where it operates. Example, whether it's a web or application. And then it has tools or skills like APIs, plugins, calculator, etc. And it might have memory too, which is optional to remember context or progress. And then it will have a reasoning loop: think, act, observe, and repeat. Okay, the best example is like a travel agent, right? If I want to plan a 3-day trip to Paris or somewhere else, I'll go search for flights, find hotels, suggest tourist, then suggest tourist spots. Okay, I'll try to find tourist spots, and then based on my preferences, I will adjust the overall, the things which I have already did, right? So LLM is also doing the same thing. It will search the flights. For searching the flights, it might invoke APIs. Okay, for finding hotels, it might invoke another API. Okay, and then for suggesting tourist spots, it might invoke another API. And finally, based on your preferences, right, previous history or whatever, it will see, and then it decides, okay, these are the best options you might have in the 3-day period or 4-day period, whatever, depending upon the season. Maybe it is summer, winter. It decides on what spots you can visit based on the timings and everything. It will suggest what is the best time you can visit. All that LLM can decide, and that is an agentic system. So AI agents is nothing but an LLM with lot of tools and information available at hand for it to decide. That's AI agent. Okay, so these are the use cases. Huge automated workflows. So I was talking about DevOps team. DevOps team nowadays, most of the things they try to hello. Someone was speaking, sorry. Okay, so DevOps team wants to automate most of the workflows, right? So they might use LLM for automating their workflows. Travel planners, I already talked about travel planning, how you can do through agentic system. DevOps assistants, again, automated workflows you want to implement, or DevOps assistants you want to implement. It's up to you what you want to do. You can have DevOps assistants also, like Copilot agent. Copilot agent is already part of most of the IDEs. You can use that as well. So there are tons of use cases you can build using agents. Okay, so summary, I think we are almost 5 minutes over. So summary is generative AI equals new era of content creation. It is different from traditional ML, which we already know now, and it has many enablers like prompting, RAG, and agents. These are the key enablers for generative AI. And these are the common questions which I have already put. And if you have more questions, we can discuss them. Will AI take away our jobs? AI will definitely automate some of the repetitive or routine tasks, but it will also create new jobs. Okay, and adapting, as long as you adapt, reskilling and adapt to the work alongside AI, that is the key, right? How AI is different from traditional software. Traditional software follows fixed rules. AI learns from the data and adapts, making it more effective in complex and changing scenarios. Can AI be biased or make mistakes? Yes, definitely. I talked about that already. AI reflects the data it has been trained on. If the data is biased, so the AI is. Ethical AI and human oversight are essential. So there was I'll talk about that point if you don't have any questions. Is AI safe? Can it go wrong? Today's AI is narrow and specific, task specific. The real risks are misuse, lack of transparency, and unintended consequences. So I recently heard Expedia had to pay $1 million for a lawsuit because one of the chatbot they had built, it actually committed something, gave an offer to a customer with because they had not put guardrails, proper guardrails within the chatbot, and it gave an offer which was not even, they were not even offering that particular offer. So it was and then when Expedia, so customer took a screenshot, but Expedia denied it later, saying that it was an error, we cannot pay for it, we cannot give that offer. And then the customer filed a lawsuit, and then the Expedia had to pay $1 million as a compensation for that customer. So it is very risky if you don't put proper guardrails within your applications which you are building out of from chatbot, because LLMs are, as I said, they are very creative, innovative in nature, and sometimes they might give some response which you are not expecting, and that's why we need to put proper guardrails within the AI. All right, I think that concludes my demo. If you have any questions, we can take that up. Otherwise, we can drop for today.
Hey, thank you for the presentation. That was very informative. I just wanted to ask, in terms of this, I'm not sure if this is only an introductory meeting that you're having, or is this something that you're willing to follow up and continue in the future?
Yeah, I want to continue if there is enough interest in digging through a specific topic, because as I said, AI is very broad concept. We have several things which, like for example, if I take just RAG, right? For RAG itself, I can take almost 3 to 4 classes. If I go for agents, I can have 5 or 6 classes for agents. So it all depends on the interest. If you guys show, if you want more deeper understanding of specific concepts within AI, I can definitely dig through them in following classes. I'll put a survey. Let's see how people respond. So if there is enough interest, I can probably go with more classes on specific topics.
Yeah, that's very helpful. I think there are different goals from different people. Maybe some folks are just wanting to learn. Some folks want to get into the industry. Would you be able to cater to all of those, or you just are doing for informational purpose?
We can do either whatever helps, right? I mean, my goal is to make our community aware of what AI is and also skill them in the AI field so that it's easier for them to find jobs in the future, because we are seeing so many things happening currently in the job market because AI has taken over most of the jobs now. And the more and more we invest time in learning this, it will definitely be helpful for our future job scenarios. And that is my goal, to make you all learn this new field. So yeah, definitely if you want to learn more about it, yeah, I'll be interested in taking more classes. All right, that's all I had. Thank you all for joining, and I'm hoping it was very helpful. And if I'll post this class on YouTube, and if you have any questions, you can reach out to me directly on WhatsApp, and I will be able to answer them. But as I said, let's continue this learning, and will take as and when we progress, we will learn more about different concepts, and gain deeper understanding. So since most of us are technical in nature, the next class, what I will do is I'll put some code. I'll do some code. We will do some live coding, and we will learn some of the concepts, building some simple applications for RAG and agents. Okay, so let us do that. All right. Thank you all. Talk to you soon.
Thank you so much. Assalamu alaikum.
Waalaikumsalam.